Yeah, if you watched part one of my composition videos, you know that I dedicated it to the blob. And in part two, that still holds true. So in part one, I actually go through the story about how I'm relating it and where it ties into the movie. If you actually want to watch that video, I refer you back to it. I'm not going to tell the story again, other than the part about the girl's face caving in. Looks a lot like what you would see as a composition of functions. So in this one, in part one, by the way, we found the f composed g of 3 equaling 9 and the g composed f of 3 equaling 19. I'm going to show you another way to do that problem, this time generically, if you have f composed g of just the variable x, and likewise f composed f or g composed f of just the variable x. All right. So remember, working from the inside out, right? Just like the blob worked with on the girl, is way from the inside out. So we're going from the inside out here, and I'm going to plug the g function inside my f function. Okay, so what's happening here is I'm going to take this 2x plus 1 here, and I'm going to stick that whole thing in for that x. So it's a weird substitution because I've got something with x in it substituting in for where there was an x. Okay, so basically what you're doing is you're throwing this x away and you put the 2x plus 1 in its place. And this is the reason I like to use different colored markers to illustrate this. So now we're looking at 2x plus 1 quantity squared, quantity squared, like that. Okay, so hopefully with the different colors you can see how they're relating here. You can multiply out this binomial if you like. It's a perfect square trinomial now. It's going to be 4x squared plus 4x plus 1. They're both equivalent statements. You could probably write them either way. Okay, now let's find g compose f of x. So this time I'm going to take my, erase what I can here. Hopefully it doesn't get too much damage by doing the eraser here. Basically, I'm going to take my x squared in my f function, and I'm going to put it in for the x in my g function. So this x is gone. In its place will be x squared. So it looks like this: 2 times the x squared plus 1. And that's it. I can't really simplify that anymore. Now, if you watched part 1, like I said, we figured out what f of g of 3 was. We found that to be 49. So here's my point. If you generically find out what f of g of x is, now what we can do is we can use one of these two guys, this 2x plus 1 quantity squared, or 4x squared plus 4x plus 1, either one, to find out what f of g of 3 is. I'll use the first one. It looks like it's easier to work with. So f of 3, or excuse me, nuts. My f of g of 3 would equal my 2 times the 3 plus the 1 quantity squared. So that's going to be what, 6, 7 squared? Hey, look at that. It's 49. Huh. That 49. Well, that's kind of cool. Well, if we find g of f of 3, g of f of 3, using this guy here, that'll be 2 times the quantity of 3 squared plus 1. That's 2 times 9 plus 1. Hey, what do you know? 19. So the point being, you can generically find some kind of a variable formula representation of what you're trying to find your composition of, given a specific number. Or you could do what we did in part 1 of the video, where you plug in the 3 into one of the original functions here, and then take that solution and plug it into the subsequent formula. Okay, so there's a couple ways to approach that. Hopefully that helps. Thanks for watching.